Thank you, Carlo, for the introduction. The topic for this presentation is description and quality check for simulation data. My name is Sebastian Tuttas. I'm from 3D Mapping Solutions. We are experts in kinematic surveying and the creation of simulation artifacts like HD maps and surface models. And I will make the frame around this presentation, guiding you through the first and the last slides. Here you see the agenda. This presentation is a common result of the data provider group within the Gaia-X for PLC AAD project. First, I will introduce the members of this group together with our user story, which will motivate the activities within the project. We will give our view on the aspects why we need simulation data in a common data space and what are the challenges behind it. Afterwards, we present approaches to cope with these challenges, and finally, we give a demonstration of a marketplace which shows how simulation data can be offered, and at the end you will hear me again with the final words in this presentation. I will start with our user story and introduction of the team behind this presentation. Our user story is mainly about finding the appropriate data for a certain simulation task in a large data pool where I not only want to find the necessary data, but also want to combine different data types from different vendors. The data provider group focuses on the static scenes as well as the scenarios. We are not only some of the data providers within this project, 3D Mapping Solutions, TrianGraphics, and Virtual City Systems, but also data consumers like BMW and DLR, and service providers, which are Perpetuum Progress and ASCS. Together, we are covering the whole data flow within the marketplace. Our user story or assumed scenario is that there's a joint investigation on ALKS of BMW and DLR, but with different scopes. One is sensor validation, the other one is driver-in-the-loop simulation, but both should work on the same assets to have comparable results. Here we have the connection also to the previous presentation, which was about combining a virtual environment with virtual sensors for a sensor simulation or validation of an LKS. In the following, you will meet the people named on the slide. In the next part, Arben Parduzi from BMW will present why we need a common data space for the simulation artifacts based on the data consumer perspective. Mirco Nierenz from TrianGraphics will then show how the data in the marketplace can be validated or enriched with additional metadata. After that, Sharique and Simon Pogoni from Perpetuum Progress will show the data flow in a demonstration with their marketplace oval. Finally, I will give a short summary and show the real data sets we provide within the project. I also want to name the other contributors in this group, which are Johannes Demer from the SCS, Max Sindram from Virtual City Systems, who will present additional content in their virtual booth later, as well as Finn Hoyer from DLR, who brings in the perspectives, or among others, on the scenarios. And now I will hand over to Arben.
Thank you for the introduction, Sebastian. My name is Arben Parduzi, and I'm a research engineer at BMW's Driving Simulation Center. Today, I will be discussing the daily challenges and struggles that we face when integrating various data assets for our simulations. By the end of my presentation, I hope to make clear why we need a common data space and what features should be included within this data space. Let's consider now an example in which we want to evaluate an ADAS function in terms of acceptance and trust. To achieve this, we have to establish a driving simulation environment in which we can examine the criteria. To give you a better understanding of the data assets involved, I've provided an example on this slide. Here you can see examples for data artifacts used for the simulation. Building a driving-in-the-loop simulation requires several key components. Firstly, we need the road network, including the general geometry of the road and information about road signals and objects within the road. Next, we need a scenario description, which is in the context for our use case, means a file containing details about the number of other agents present, such as other cars, pedestrians, and how they should behave and interact. The third component is a file that includes road excitations in higher resolution, which can be used as an input for the driving dynamics simulation. And lastly, a proper 3D visualization of the environment is necessary. It's crucial that all of these data artifacts are consistent and match each other, including the used coordinate system and other parameters. So as you can see, developing a simulation that reflects real-world conditions involves a lot of data modeling and integration. After explaining the individual simulation components for our specific use case in simulation software, there is another factor to consider: the variety of software products. In addition to the multitude of data formats that must fit all together, there are numerous simulation software components, as I simplified on the slide. The key message is that the variety adds another layer of complexity. Each software package interprets some of the data artifacts differently, significantly increasing the integration effort from the user's perspective. On the following slide, the situation will be clarified again using the example of 3D visualization. 3D visualization is an integral part of the virtual driver-in-the-loop simulation. I need a virtual 3D representation of the environment in order to localize and navigate myself as a human driver in the virtual world. And for this data fragment as well, different simulation frameworks process different data formats and dialects. On the left side, we can see a selection of input data for creating 3D environments. Examples are point clouds, city GML data, or OpenStreetMap data. From these input data, a multitude of output data and with their own features arises, which are relevant for different target systems. As a research and development engineer, my main question is, how can I find the correct data that is suitable for my simulation software and my research question? Therefore, as a user, I have three requirements. Firstly, we need a fast and broad access to the offered simulation artifacts, which is the intended goal of establishing a marketplace within the GaiaX ecosystem. Secondly, while accessing the offers, we need a common and consistent description of the data artifacts available within the GaiaX ecosystem. And last but not least, we have to be sure that the artifacts we want to purchase are validated and suitable for our simulation software, requiring validation services within the GaiaX ecosystem. In the next part of this presentation, Mirco Nierenz will introduce the actual status of the developed solutions to tackle these challenges. Thank you for your attention.
Thank you, Arben. Let us now come to our solution approaches. My name is Mirco Nierenz. I am Managing Director of TrianGraphics from Berlin, and we are mainly involved in the project with the creation of 3D environment models, but also with the validation and findability of the data assets. The first point is the validation of the data assets. In the marketplace, it should be ensured that all data is uniformly and fully tested in order to avoid incorrect purchases. For the different formats of the data asset, validation tools have been available so far, but they are insufficient or cannot be used in the GaiaX ecosystem. We have collected this test of the tools and implemented them as a data service as an example. For this purpose, the provider's data is checked during the registration. If defects are detected, we report it back to the provider. For the open formats such as OpenDrive, OpenScenario, OpenCRG, the syntax, the semantic, and the data content is checked. It's also being tested that the data asset is usable for certain platforms, such as BMW Spider System. The test library will be further extended and made available as open source after the project. This guarantees a uniform quality in the marketplace, and the consumer can assume that it's run in a system. The next step is the extraction of metadata. In order to find the data asset in the marketplace, it must be possible to find them via a product description. The description should be consistent, e.g. for calculations such as the total length of a road network or the use of the same unit. The data asset should also be described in complete detail. We have also done this by using a data service. This service analyzes the supported data asset for the open formats and calculates the required product description, so-called self-description. This must then be completed by the user, as not everything in the data can be extracted. This self-description still need to be authenticated and can then be used as a product description in the marketplace. This way we ensure that all information is always entered and generated in a consistent manner. Now let's come to the advanced search. When the customer search for data in the marketplace for their simulation, the product description may not be enough and the data asset need to be analyzed in more detail. The customer can first filter the product description and apply a data service for advanced search. For this, he can use some predefined search scripts. For example, he can search for 4-line highway sections with 2 km length. These scripts will be further completed after the project. It is important to ensure secure access to the data asset, as it may be located on the data provider server. For this purpose, a trusted connection is established, and the data service with a search script is executed in a secure Docker container. In this way, the customer can be sure that the data contains the desired scenario and buy it without hesitation. The data services can already be tested on the Oval platform, which Sharique will now demonstrate.
Hi, I'm Simon from Perpetuum Progress. Perpetuum Progress is a service provider that is specialized on enhancing simulation assets to prepare them for various simulation platforms. These simulations are used to virtually validate driving assistant functions, for example, the automated lane keeping system. When we started in this GaiaX project, we were looking for a solution to identify whether a simulation asset is compatible with the simulator before the purchase. To address the problem of quality control before purchase, we developed an open validation platform called Oval. Oval is a fork from the open source Ocean protocol, and it allows the execution of algorithms on remote datasets. This computing paradigm is called computer data, and it enables data consumers to run an algorithm on a dataset without owning the data itself. So how does it work? There's the data owner that offers the dataset, and there's the data consumer who wants to use the dataset. The data consumer is not sure whether the dataset fulfills the required quality standards. And that's where the algorithm owners comes into play. Other parties, so-called algorithm owner, can offer algorithms that can be executed on datasets if the data owner gives their permission to do so. Algorithms can be, for example, a script that validates the dataset, or even a whole simulator to validate if the dataset can be simulated using that specific simulator version. So let's see how that works in detail. First, the data consumer starts the validator compute job on the dataset. A Docker container with the algorithm is deployed into the infrastructure of the data owner. Then, in the third step, the algorithm is executed on the dataset, and the data consumer gets a quality certificate of that specific dataset without owning the dataset. The same process works with whole simulators too. So the data consumer wants to test if the dataset can be simulated using a specific simulator, so he starts the simulation compute job on the dataset. The simulator is deployed into the infrastructure of the data owner and executed. The data consumer gets a video and logs of the simulation, and now the data consumer is equipped with a quality certificate and the simulation results that should provide the data consumer with the required information to make a decision to buy the dataset. My colleague Sharique will now give you a live demo on how this process looks like on datasets that are developed in this project.
Thank you, Simon, for giving us the overview of Oval. My name is Sharique and I will present here the two use cases mentioned earlier. For validation tool, I will use Gaussian track from 3D mapping. The platform is available online. This is the home page with clustering of datasets. I will go to catalog page and will look for Gaussian track. I can either click on the dataset or on the map to open the details view. In this view, the description of the dataset can be seen along with the map view zoomed to the dataset location. Also, the tags can be given to each dataset. On the right side, the algorithms or the services are made available for selection. Once the selection is made, the compute job can be executed. We need to make a couple of confirmations. After this, it will ask to sign to start the job. After signing, the job will be started and the status can be seen under the show arrow. As we can see, the process has started. It will take few seconds before it is finished. So to save time, I executed it earlier to show the end result. There are two results or reports. One is a text file showing the errors and warnings found in the Open Drive. And the another one is an XML file with errors and warnings embedded in the Open Drive elements. Moving ahead to the second use case, here I will use testbed Lower Saxony track from DLR and extract the metadata out from it using the tool Open Drive Metadata Extractor. In similar fashion, we go to the Oval frontend, look for test file Niedersachsen or Lower Saxony and select it. The details view will open with the descriptions of the track and the algorithms will be available for selection. Select metadata extractor and execute compute job. After the confirmations, the job will be started. Again, to save time, I have pre-executed it and will show the result. The result files are saved on chain. There is one result file available from the algorithm. It is a CSV file with the extracted metadata information from the track file. So these are the metadata extracted from Open Drive. So in this view, similarly, I can select any other available and allowed algorithms to run over this track. For example, ESMini or Open Drive Viewer. For the sake of demonstration of the feature, I will quickly show the pre-executed job with Open Drive Viewer. Here, there are two result files. One is the log file of the Open Drive Viewer, and another one is a video of scenario on the track with randomly placed traffic. Of course, the resolution and the traffic properties can be adjusted. So that's it from my side. Thank you. Now I will give it back to Simon to give the outlook of Oval.
Thank you, Sharique, for the live demo. Now I want to give you some insights about the upcoming milestones in the Oval development. Our first milestone is the integration into the federated catalog. We want to enable assets that are published on other data spaces to be validated using Oval. Our second milestone is that we want to use self-descriptions as a format for quality certificates to simplify the general validation process. Last but not least, we are working on an asset type specific metadata format to improve the search feature. Thank you very much.
Thank you, Simon. I will now conclude the presentation with a short summary. We've motivated why we want to find simulation data in a common data space and that there are several challenges. For example, in finding the correct version for a certain simulation environment or compatible datasets. Then we showed possibilities how to check and describe the data in the data space to make the mentioned task more easy. And finally, we presented what can be possible on such a platform based on the test datasets using the technologies which are applied in Gaia X. As a last point, I want to show what data we are currently providing for the project members for testing metadata descriptions or validation tasks. Beside a minimum HD map example of an highway, we have an urban dataset including HD map and different kinds of 3D models, as well as the highway from the Testfeld Niedersachsen, where we have all kinds of data types and also real measurements, what was presented before, which are from the data acquisition campaign performed in June. Finally, here are two screenshots to show what is behind the datasets. On the left side, you see the road logic described by an HD map for the real-world marketplace in graphing, as well as the corresponding 3D model. With these images of a digitalized real marketplace, which we want to offer in the GaiaX marketplace, I want to conclude this presentation. Thank you for your attention.